Java coders. In our last video, we learned about the increment and decrement operator. Today, we are diving into the world of bits and bytes with the bitwise operators in Java. Java has 6 bitwise operators: AND, OR, XOR, NOT, left shift, and right shift. These operators work on the binary representation of integers. That means it is only going to work on zeros and ones. Let us see these operators in action. The first one is the AND operator. This operator returns 1 if both bits are 1 and 0 otherwise. Let's understand this with this example. In this example, we have an integer a which has been assigned the value of 5 and integer b assigned the value of 3. We need to get the result, which is basically the AND operation on a and b. Let us understand this in more detail. As I already told you, this completely works on the binary representation of integers. So basically, 5 becomes 101 in its binary form and 3 becomes 011 in its binary form. Now, when we are computing the result, let's see how does this work. As per the principles of bitwise AND operator, the output is 1 if both the bits are 1 and 0 otherwise. So over here, if we just consider 1 and 1 is going to return the output as 1. Here 0 and 1, since one of the bit is 0, this is going to remain as 0. Here again 1 and 0, since one of the bit is 0, this is again going to return 0. Now, what is the final output going to be? Is it going to be 001 or something else? Remember, the final output is going to be in the form of an integer number, basically in its decimal form. Let us quickly run this and check. As you could see, this output is a simply 1. That's how the bitwise AND operator works. Now, let us go ahead and understand the next operation, that is bitwise OR operator. In bitwise OR operator, the output is 1 if any of the bits is 1. But if both the bits is 0, the output is simply 0. Let's do this using the same example. Over here, let me simply just change this AND operator to a OR operator. Now, let us understand what this output is supposed to be. 1 and 1. Considering any one of the bit is 1, this output is going to be 1. Now, 0 and 1. Since here one of the bits is 1, the output is 1. Again 1 and 0. Again here the output is going to remain 1. When we run this program, we get the final value as 7, which is nothing but the simply decimal conversion of 111. That was about the bitwise OR operator. Now let's look at the XOR operator. This operator returns 1 if the bits are different and 0 if they are the same. Jumbled up? Don't worry, we will solve this using our example. So let's change this operation simply to an XOR operation. Now, as I told you, this operator is going to return 0 because both of these bits is 1. Now, 0 and 1. Since both the bits are different, it is going to return 1. Here again, both the bits are different, so it is again going to return as 1. So, let's quickly understand what our final output is going to be. It is going to be 6, which is nothing but the decimal representation of 110. That is all about the XOR operator. Now, let's go ahead and understand the fourth bitwise operator. That is nothing but the NOT operator. The NOT operator simply inverts the bits from 0 to 1 and 1 to 0. Let's see how we are going to do this. In order to do this, let us simply consider only the integer a. Let's assign the NOT operator for it. So, as I told you, it completely So as I told you, it interchanges ones with 0 and zeros with 1. So this is how the output of 101 looks like. It is simply represented as 0, 1 and 0. So let's see what is our final output. Okay, it says there is an error. Yeah, so let's simply put a semicolon. And run our project. The output is -6. This -6 happens because the computer internally performs a 2's complement on it. But that is right now not something to be discussed in our Java course. Now let's dive into the shift operators. Java has two shift operators, left shift and right shift. These operators shift the binary representations of the integers either towards the left or towards the right. Let's start with the first one, the left shift operator. This operator shifts the bits of the number towards the left and fills 0 on the voids left as a result. Let's understand this with the help of an example. Here, we again have an integer a which has been assigned the value as 5. Remember, its binary representation is 101. Now, I want to make use of this left shift operator. So, let's see how it works. Let's take a variable called as result, which will store the value obtained after performing the left shift operator. Here, we have this variable called as result, which will store the value obtained after applying the left shift operator. Let's see how to do this. Over here, we are saying that shift this binary numbers with one position towards the left. Let's see what this output is going to be. Since we are going to shift everything towards one position, so this becomes 101 and 0. Basically, what we did is we shifted this one position and whatever was remaining, we have just simply added 0. Let's quickly check what is the output. The final result is 10. This is nothing but the decimal representation of 1010. That was about the left shift operator. Now, let's try and understand the right shift operator. This operator shifts the bits of the numbers to the right and fills 0 on the void left as a result. Let's understand this using the same example. Instead of the left shift operator, let us simply make use of this right shift operator. Considering this, we are saying that it should shift one position. So over here, 101 simply shifts and becomes 10. Let us see what is the final output. The final result is 2. That is how the right shift operator works. What we have learned is making use of left shift operators as well as right shift operators in Java. In this video, we learned about the different bitwise operators. In the next video, we are going to understand more about relational operators. So stay tuned with us.